Hello there. Today I'm going to be working through a vectors question from the January 2012 Edexcel past paper. This is an M1 question. It was question 7 on that paper. And basically the question tells us about a boat P that's moving with constant velocity minus 4i plus 8j kilometers per hour. And for the first part we have to find the speed of the boat P, and this is for 2 marks. So I'm going to start by saying the speed, that's equal to the magnitude of the velocity vector. So the velocity vector is minus 4i plus 8j. You have to find the magnitude of this using Pythagoras' theorem to calculate the speed. So using Pythagoras, I will have minus 4 squared plus 8 squared all square rooted. Now if you were to write this, that works out as square root of 80, which you can either write as a third, 4 root 5 kilometers per hour, or if you were to work it out with a calculator and round it to 3 significant figures, it would be 8.94 kilometers per hour. So that there is the speed from the velocity vector minus 4i plus 8j. Where the marks are allocated here, you get a method mark for knowing that to find the speed you have to find the magnitude of the velocity vector, and you get an accuracy mark for either the third form or the decimal form. So it's a simple 2-mark question. That's part A. Okay, so moving on to part B. When t is 0, the boat P has position vector 2i minus 8j. So that is its initial position vector, and that's measured from some fixed origin. At time t hours, the position vector is given by this general vector p, and we have to find this general vector p in terms of t. Now, to do this, there's a formula that's used a lot in M1 vectors questions, which is r equals r0 plus vt. This is a formula you have to know, and basically it means that for any moving particle, r is the position vector at any given time, so it depends on time, and that position vector is given by the initial position vector, so that is the position vector at time t equals 0, plus its velocity vector times by how much time has elapsed. And obviously for different values of time, that will give you a different position vector. So what I can do is I can substitute straight into this formula for the question at hand. So instead of r, which is the general position vector at time t, we're going to write p, because that's what we're told in the question. r0, which is the initial position vector, that's the position vector when time t equals 0. Well, for my boat p, that's just 2i minus 8j. So I'm going to substitute 2i minus 8j for r0. And from part A of the question, I know that the velocity is minus 4i plus 8j. Okay, so I'm going to substitute that for my velocity of my boat. So it is plus minus 4i plus 8j, and it's that times my value of time. And obviously depending on what value of time I have will change the answer here, will change the actual value of the position vector. But that is a general expression for P, and it depends on time. I'll just close this. So in terms of where the 2 marks are allocated, well, the 1 mark is allocated here, it's just a B1 mark, which means it's not a method mark, it's not an accuracy mark, it's just a completely unrelated mark from everything else in the question. If they see this written down for part B, then you get that mark. Okay, so for part C, it says a second boat, Q, is also moving with constant velocity. And at time t hours, the general position vector of Q is given by this lowercase q, and that's 18i plus 12j minus t times 6i plus 8j. And what we have to do is find the value of time, value of t, when P is due west of Q. So if you were to imagine P being due west of Q, P would be here and Q would be here. So P, you'd have to head west to get from Q to P. Now if these are measured relative from some fixed origin, let's call this 0, and we have the vector to get from the origin to P is this lowercase p vector, which we worked out in part B of the question, and to get from the origin to Q, we would go along vector Q, which is given here. Now, if P is due west of Q, this vector to get from P to Q, which I'm just going to call PQ, that is going to be equal to some constant times I. So we're not moving up or down at all. Because we're moving purely in the positive I direction to get from P to Q, that must be some amount of I. Okay, there's no j component to this vector because it's not up or down at all. It's purely across. So if I was to write PQ, so how we get from P to Q using these vectors, well, to get from P to Q, I'm going to go back down the little vector P, so that would be minus P, that would get me down to the origin, and then I will travel along lowercase q to get to the position of the ship Q. So it's going to be plus Q. Or in other words, I can say that's just Q minus P. Now what I'm going to do is I know my value of Q, that's here, it's a vector with i's and j's and it depends on time, and I know my value of P. I worked that out in part B of the question, and again that's written in terms of I and J and it depends on time. So what I'm going to do is I'm going to substitute my values of Q and P into this expression and set that equal to some constant, which we don't need to find, times I. And we're going to solve that to find the value of t, value of time, so that this is the case. So if I was to substitute, remember we're going to be doing Q minus P equals lambda I. If I substitute for Q, then that is 18I plus 12J minus T lots of 6I plus 8J. And then if we're taking away P, that will be minus 2I. Because it was minus 8J, taking away minus 8J will be plus 8J. And then we're taking away T times minus 4I plus 8J. And I'm going to set this equal to lambda I. Now if I was to expand these brackets and then simplify this whole expression down, I would eventually get to 16I plus 20J plus T times minus 2I minus 16J, and that is equal to lambda I. So that is my expression for P to Q. That's how I get from P to Q. So because there is a 0j component on the right hand side, for this equation to be true, the j components on the left hand side of the equation must cancel out. So they must be equal to 0. So I'm going to equate the j component. So I'm making it clear to the examiner what I'm doing. And what I'm going to do is I'm going to say, well, 20j plus minus 16t, so take away 16t, that they must cancel each other out. They must be equal to 0 because on the right hand side it's lambda I. So if I was to solve this equation, that will find me the value of time that's required. So obviously that tells me that 20 is 16t, and dividing both sides by 16, tells me that t is 5 over 4. So that is the value of time, so that P is due west of Q. So in other words, to go from P to Q, you would be travelling along a vector some constant times I, and that's the value of time that is required. Now, in terms of where these marks are allocated, this is a 3-mark question. You don't get any marks for drawing this diagram. I was just drawing the diagram to try and show you how I know that P to Q is lambda I, and how I can find P to Q by doing minus P plus Q. So you don't actually get any marks for this, but you may want to do it in an exam just to make sure that you're entirely clear on what it is that you're doing. What you would get marks for, though, is finding an expression for Q take away P, and equating that equal to some lambda I. That is 1 method mark. And accurately equating the J's is an accuracy mark, and finding the final value of time t is a 3rd accuracy mark. Now, there are shorter methods, shorter ways of answering this question, but doing it this way, by getting a general expression for the vector from P to Q, is quite handy, because it will be useful in part C of the question. The one thing you do have to be careful of is in this stage here, when you're expanding and simplifying, just being careful that you don't make any careless mistakes with the minus signs or anything like that. So part C of the question would like the distance between P and Q when P is due west of Q. So what we can do is, I know that when P is due west of Q, my time t is equal to 5/4. This is what I worked out in part C. So taking my general expression of P to Q, which was 16I plus 20J plus T times minus 2I minus 16J. This is what we worked out in part C of the question. It's just here, my general expression for P to Q. What I'm going to do is I'm going to substitute my value of time as 5/4, because that is the time when P is due west of Q. So if I substitute that value of time in there, I will get, and expand the bracket, I would get 16I plus 20J. Now 5/4 times minus 2 will give me minus 2.5I. And 5/4 times minus 16 will be minus 20J, and that simplifies to 13.5I. Now this makes sense if you think about it. Because it's due west of Q, then this vector will only involve an I component. There won't be any J component, because that would mean that there's slightly up or down, which means it's not due west. It has to be straight across for it to be due west. So if to get from P to Q you have to travel the vector 13.5I, that's just a vector in the I direction, which is travelling straight across, and it's of length 13.5. I'm sorry about this, keeps on popping up. So the distance between the two, given that it is 13.5I, if you were to find the magnitude of that, it's the square root of 13.5 squared, which would just give you 13.5 kilometers. You don't have to do that though. Just because you know it's 13.5I, the length of that vector must be 13.5 kilometers. Now where the marks are allocated here, for substituting your value of time into a general expression for PQ, you get a method mark. For getting the general vector equal to 13.5I is an accuracy mark, and knowing that the distance, therefore the magnitude of this vector is 13.5 kilometers, that's your 3rd accuracy mark. And the thing is, by doing a slightly longer, slower method in part C, that sets us up really nicely to just substitute straight in part D, and that's where the 3 marks are allocated. So that was January 2012 Edexcel M1 past paper, and that was question 7 on vectors. Thanks a lot for watching, and I hope to see you again sometime soon.